Hi guys, today we're going to write quadratic equations given a vertex and a point. Now we're going to use the quadratic vertex form. Y equals a times x minus h squared plus k. The hk part of the formula is going to be our vertex. So this would be the x and y value of the vertex. The x and y in the formula are going to be the given point from anywhere else on the parabola besides the vertex itself. Now, keep in mind this is going to be in X, Y format when we see it as a point. We want to be able to find A so we know if there's any kind of stretch or compression, vertical stretch or compression, or if there's a reflection to it. So to do that, we're going to plug in the point and the vertex and solve for A, and then we can rewrite the equation into the actual vertex format. Okay, so let's look at an example here. It's always a good idea to label your points. So I'm going to label my vertex as HK, and I'm going to label my point as XY. This way, when I go to put it into my vertex form, I know where everything goes, okay? And I won't get, hopefully, won't get mixed up with which number goes where. So we're going to use y equals a times x minus h squared plus k. So I'm going to plug in my point first, the x and y point. So y is a -8 equals, we're looking for a. And I'm going to go ahead and put in some things that are always going to be in there. Okay. Our x is a -5. Our h from our vertex, the x coordinate of our vertex is -3. And then k is the y coordinate of our vertex, and that is -6. Okay. We've got a lot of extra signs going on there. So I'm going to suggest, it's always a good idea just to go ahead and simplify out the signs. Okay. So we're going to do -8 equals a times -5 plus 3 squared. And that plus a negative can just be a -6. Let's solve for a. First thing we want to do is simplify that right side of the equation. Use a PEMDAS order. We're going to take care of what's inside the parentheses first. So we're going to have -2 squared. And then we're going to take care of the exponent. So we're going to square that -2. And at this time, we're going to go ahead and put this coefficient in front of the a. So -2 squared is 4. Okay. And then -6. And now we've got it down to a two-step equation for us to solve. We are going to add 6 to both sides and then divide by 4. Okay. So when we add 6 to both sides, we get -2 equals 4a. When we divide by 4, we end up with a equals -1/2. Okay. -2/4 is going to simplify to -1/2. So then our equation in vertex form, y equals, we're going to take this -1/2 right here. And parentheses x. Now, we're going to take the negative plus -3 or minus -3. The hk are going to stay in our equation. So because it was a minus a -3, it became a +3. And then the 6 became a -6. Okay, we're going to do -6. So again, the vertex is at -3, -6. So where those numbers come from, our a value after we solved was at -1/2. Now, we can also graph it. As long as we have vertex and another point, we can graph at least one other point. Okay, so -3, -6, this is our vertex. And because we found out our a value is a negative number, we know it's going to open down. Okay, it's going to look like a hill. Our other given point was at -5, -8. Okay, this was our given point. And thanks to the brilliance and magic of the axis of symmetry, we can use the property of axis of symmetry to be able to find another point across the axis of symmetry. So this -5, -8 is going to be mirrored over here at -1, -8. Then we're not going to have enough space to put any more points on there. So we're going to go ahead and connect these. Remember, parabolas are curved. And I'm having a hard time drawing a curve right now. So parabolas are curved types of functions. So there we go. All right, doesn't have to be perfect, but there we go. All right, let's go ahead and look at another example. Pay attention to the information that's being given to you. This time it's giving us the point first and then the vertex. So here's my xy, and my vertex over here is going to be my hk, right? When we plug it into our formula, into our vertex format, okay? That's how I like rewriting it on here, just to make it so I know where everything's going to go, all right? So we're going to put our 4 equals, we're looking for a, our x is 2, and then we do our vertex, our h is 3, our k is 6. And we could start simplifying the right side and then solve. So 2 minus 3 is going to be a -1. And then when we square -1, we'll get a +1. Now, normally we wouldn't have to write the +1 in front of our a as a coefficient, but we're going to do it today just for purposes of making sure we know where all our numbers go and where they're coming from. All right, all we have to do to finish solving is to subtract 6, and we find that -2 equals a. So in vertex form, our y equals, and again, here's what we looked for, our -2 times x minus 3 and squared plus 6. Again, we can graph it, and if we can get more points, great. But we're gonna go ahead and graph this at 3, 6 is going to be our vertex. Okay. Again, it's a -2, so we know it's going to open down. Given point is at 2, 4. So let's go ahead and bring that down. Put in our axis of symmetry. So then we can mirror this 2, 4 around over here to 4, 4. Okay. And we can find more points on our parabola. If you remember graphing parabolas, we talked about how parabolas have excuse me, there we go. I'm trying to shift it over and it didn't want to shift. All right, Parabolas have, when we graph them, a pattern for getting from one point to the next. If there's not a vertical stretch or compression, that pattern is that it goes over 1 unit and up 1 unit, over 1 unit and up 3 units, over 1 unit, up 5 units. When we have a vertical stretch or compression, that 1, 3, 5 pattern gets multiplied by that A value, okay? So I know I have a vertex at 3, 6. I know I have a point at 2, 4. And by axis of symmetry, we were able to find another point at 4, 4. Okay? But let's go ahead and see if we can graph one more point on each side of our vertex. So if I do 1 and 5, okay? And I'm going to change colors here. This here, we're going by 2. Okay, we've got a difference of 2 in each direction. Using our 1, 3, 5 pattern, that would be 1 times 2. Okay, because it got our 1, 3, 5. We want it to be a 1. And then for the next one, we want it to be a 3. Okay, because the 1, 3, 5 pattern, the next pairing out would be 3 units below that first pairing. Okay, we're multiplying these by the A value, and we're just doing a positive 2 because a negative really just tells us that it's moving, that it's opening down. Okay, that was reflected around that x-axis. All right. So by doing this, I see that we needed to, instead of it being a 1, 3, 5, it's going to be a 2, 6. And then the next number would have been 10, so the next difference. So 2, 6. So if I add 6, sorry, if I subtract 6 from 4, I'm going to get down to -2. And then I will have points at 1, -2, and 3, -2. Sorry, 5, -2. That gives us 5 points. We can make a really nice parabola with that. Do you have to put 5 points? No. You can graph just 3 of them. My little parabola there doesn't want to connect to my points here. Let's try this again. But the more points that you can graph, the nicer your parabola will look. Okay? So that's what we want to do. All right, guys, so that's our examples on how to write a quadratic equation when you are given your vertex and a point. And for my algebra students, if you are watching this as part of algebra class for me while I'm out, your assignment is on the next set of pages. All right, ask your sub for the assignment pages. We'll talk to you later. Have a good day.